So day 2 of our 9.2 saga. Okay, we're going to do the sum of a finite arithmetic sequence. Okay, finite means it does what? It ends. Okay. Why can't I do the sum of an infinite arithmetic sequence? It never ends. I can't get to the end, so I can't. Okay, so, but could I take something that's infinite and ask you for a certain number of terms of it? Like, can I make something that's infinite finite? Can I chop it off? Yes. But can I take something that's finite and make it infinite? No. Okay, so how this goes is the sum of the first n terms, so the S sub n, is how many terms you are adding. Not the number of the term, it's how many terms you're adding. What is the last term? What is the first term? A sub 1 is the first, A sub n is the last.
So n is how many though?
Yes. And it's because, and I think I've told you guys this story, maybe not. I think I told you it last year. About Gaussen when he was a little kid. His tutor told him, can you see that green? No, you may. No, you cannot.
I kind of can.
Okay, you can see I'm writing something, but it's hard to see, right?
Yeah.
So Gaussen's tutor when he was little, because we all had tutors back then in the dark ages, didn't want to deal with him that day. Oh, look, it made a smiley face. And he told him to go add up all the digits from 1 to 100 and leave him alone. So that should have took him a while, right? And we're talking like second grade level, like kid. And Gaussen wasn't gone too long, and he came back with an answer. And his tutor is like, no way, get out of here, you're stupid, I won't deal with you. And he's like, I got the answer. He's like, no, you don't. And he's like, yeah, I do. And so what happened is Gaussen was just like, I am not adding all these things up. So he's like, I'm going to write them first. And he's writing them. And then he starts looking at it and notices, what's that? 1 and 100 is, what's that? So if he paired, and now hence the equation first and last. If he paired the equation up, or paired the numbers up, not the equation, I'm sorry. And he's like, okay, they all equal 101. How many pairs do I have? 50, because 100 divided by 2 is 50. So he just took 50 times 101 and got 5,050.
Wow.
Now, are the numbers from 1 to 100 arithmetic? Yes, because you're adding what? 1 every time. Okay, we don't think of them as arithmetic because they're just counting, but we are. Now, Gaussen, when he was in second grade, did not come up with the formula. No, but he did have the start of it. He was the person that actually sat down and thought about it.
N is how many terms?
N is how many things you are adding. A sub 1 is the first term, and A sub n is the last term. So A sub n and A sub 1 are the same exact things as in this equation. I get too close to this arrow over here and it shuts off. 1 times D. Okay. But N is different. N in the definition is the number of terms you're finding. This N is actually how many things you're adding up. Okay. So you need to know this. You need to know this. So every day you get a new formula.
Every day?
Every day. Okay, so find the sum of 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. Can I just add them
If you want.
if you want? Is it arithmetic?
Yeah. Plus
Going up by 2.
It's going up by 2. Oh, guys, sequence of numbers was just a list of numbers with commas, right? This is a series. Okay? A series just takes their signs and puts them there. Does that make sense? So a sequence would be 1, 3, 6, 9. A sequence would be 1 plus 3 plus 6 plus 9. A series you add, a sequence you list. So, do you guys want to add them up or you want to use the definition, like the rule? Let's use the rule. Okay, how many things am I adding? S sub what?
10.
Okay, S sub 10. Okay, so we have 10 over 2 because we're going to pair them, right? First term is,
1,
last term is,
19,
and obviously if 19 was negative, it wouldn't be plus, it would be minus. And so we've got, what, 5 times 20? So we have a 100. So the sum of these 10 terms is 100. I need to rework the find the sum of the 1 to 100 into the other slide because that's what we just did. Do we need to do it? You guys want to write down? Okay. So write summation notation. So summation notation involves our sigma. Okay. Sigma is a Greek S. It means sum. It means add it. When you see that, that's what it's telling you to do. Got it? So in front of that, so we have the sigma, we have a definition. Okay, so we'll have to write our definition. I shouldn't have written that there. We'll have an index. I used X, so I'm going to use X. We're going to have a starting point, and we're going to have an ending point. So lower limit, upper limit, function. Now, if we use an n, this would be f of, well, we don't want to use n's, too many n's, but you get it, right? Okay, so it says it is arithmetic. I'm not going to be nice to you on your test. I'm just going to say, do this, and you're going to have to figure out if it's arithmetic or geometric. We haven't covered geometric, but you've done it in the past, and you will again, and it'll all be clear, right? Okay, so we need summation, we need a definition, we need a rule, we need an equation. So we're obviously going to use a sub n equals a sub 1 plus n minus 1 times d, correct? So, what's a sub 1?
Is it what?
1, negative 6, plus n minus 1, and what's your difference? 4? Yep, I agree. So, a sub n equals what? 4n minus 10? So that's what you guys get? So this is my rule, my definition, whatever. Got it?
Mm-hmm.
You guys want to stick with the n, or you want to switch it to an x? You want to switch it to an I?
Let's leave that.
Okay, I'm going to tell you in the book, I think they use I all the time. Doesn't matter what I make it. No. The only thing that matters is right there. The reason why I tend not to use n is because we use n as an upper limit, and sometimes that confuses people. Okay? So, you guys want to leave it as n?
We can switch it.
What do you guys want to do? Switch it to x. I is weird usually for you guys. You want to switch it to x? Okay, so it's going to be 4x minus 10. There's my definition. Down here, I say what the index is, what you're plugging in, and we're plugging into X. We're going to start at 1. We're going to plug in 1 first, and we're going to end at what? It tells me 50. Does that make sense what just happened? Where everything came from. Now, we should check, right? If I plug in a 1, 4 times 1 is 4 minus 10 is 6, negative 6. If I plug in a 2, it would be 8 minus 10, which would be negative 2. Plug in 3, I get 12, which would be 2. So I'm good, right? My definition works. So it says write in segment notation and find the nth partial sum. Okay, so we wrote it in segment notation. Now we need to use our formula. So, how many things am I adding from 1 to 50? This formula is n over 2, right? A sub 1 plus a sub n. Okay. A sub 1. So how many things? 1 to 50. How many things am I adding? 50. A sub 1, you plug in the lower limit. Okay. In this case, the lower limit is 1. We know it is negative 6. If the lower limit was 6, you plug in what? 6. Got me? Okay, so this lower limit into, can I put f of x? Does that work? Okay, lower limit into f of x. How do I get a sub n? The upper limit. So what I'm trying to do is show you guys how to take notes, write more than what I say. Like, not more than what I say, write more than what I write. Does that make sense? I once had an instructor tell me, the notes you take are not what I put in front of you. It's what I say and don't put in front of you. Because those are those little things that make the huge difference. Okay, so what's a sub 1 then?
Negative 6.
Negative 6. And it's obviously going to be positive, right? Now, what's a sub n? How am I going to figure it out?
I thought it was 50.
No, n is 50. What did I just say right here? Upper a sub n, upper limit into f of x. So what's my upper limit?
50.
50, so plug it in. So 50 times 4
200.
minus 10,
190.
190. It's not 50, is it? N is 50. A sub n is what you get when you plug in 50. Okay, so what? 25, that one's easy, right? Times 184. I get 4,400. What do you guys get?
I got 2,000. What did you just multiply? 184 times.
I did 20.
Yeah, you're right.
I did 20 and 5.
Oh.
When I multiply by 2-digit numbers, I do, like, I always separate it. So I did 20 and 5.
It's 4,000.
Am I right?
Yeah.
Okay. I was like, well, I think it should be bigger.
Yeah.
Yeah, anytime I do a 2-digit number, I separate it.
Good are you?
Because I can't do it in my head, but I feel like I do it faster. Because then I'm not, like, moving over and you just line them up. Questions? Pretty straightforward, right? Till they throw you a curveball. This is exactly the same but this one, my n is negative. See that? Do you want to do it again?
Yeah. How is it negative?
Because I'm going down. Not the n, d. Yeah,
What
not
did we
n.
just find?
The sum. No. Let me go back. That's a good question. You're like, I don't even know what we just found. Hopefully it's there. And it's not there. Thank you very much. Okay, so we had the sum from x equaled 1 to 50, and it was 4x minus 10, right? So we found if we would list the first term to the 50th term and added them all up, it would be 4,400.
Mm-hmm.
It would be 4,400.
That was 4,600.
What was it?
No, it's 4,400.
It was 4,400. I'm sure it was 4,400.
25 times 184?
Yeah.
That's what she said. I had written down last time.
4,600. Yeah, it is 4,600.
Okay. Maybe I had 600. I don't know. I just
You
don't
said
remember.
it.
Oh, I said it? Okay. I'm sorry.
You wrote down 4,400.
Oh, I did. But I said 46.
Yeah.
Yeah, that sounds like me.
It's Emma's fault.
Okay. I'm sorry, Alex. I switched that before I checked. Sometimes I can get it back. Sometimes I can't. Okay. So use sigma notation. So I have to do my sigma notation, right? So the first thing I have to do is find the what? I don't like. Okay, so I need to just find the rule, the definition, the equation, right? So what do I got? Do you guys want to kind of do it on your own? No. D is negative 5. So I get negative 5n plus 80. Yeah. So I would write 80 minus 5n, so I don't lose my negative. And guys, that's just something that I have figured out a long time ago, that if I do that, I don't drop those negatives. I can be more accurate. Okay, so what do you guys want to use for your index again? Do you want to use x again?
Sure.
Okay, so x equals 1. If we're going to do these, guys, we're going to start at 1. We don't have to start at 1. We could start at 0, but that would completely change our equation. Okay, so then write your equation. 80 minus 5x. We have to switch the n to an x because what did we make it? X. What's my upper limit? 25. So this is our sigma notation. Right here, make sure you know that, because on your test, it's going to say, put this in sigma notation. In the past, sorry, I can't write and speak at the same time. Or summation notation. Sigma notation, summation notation, same exact thing. Okay? In the past on this test, people can't do the problem because they haven't read the instructions enough and they don't know what it's asking for. Make sense? I put your instructions exactly how they're putting them in your textbook. I use the exact same instructions. And so we need to know what those words mean. Okay, now we have to use our equation, yes? Our other equation? What is our other equation? S sub n equals
Something divided by 2. N divided by 2.
n divided by 2 times.
A sub 1 plus a sub n.
Okay, now that you saw the 100 and the 1, are you ever going to forget that a sub 1, a sub n? Hopefully not. Okay. So, what's our n? 25, because 1 to 25 is 25. What if it was 0 to 25? Then it would be 26, because we're not the spaces, we're the numbers, right? Okay. A sub 1? 75. Oh, we didn't check our equation. What?
Minus 45.
Minus 45. Where'd you get 45?
I did, I put a sub 1 in the thing.
You mean a sub,
Oh, yeah, Ace of, I put 25.
that you put 25, the upper limit. Okay. So 5 times 25 is 125, right?
Mhm.
And then 80 minus 125 is 45. I knew you were right. I just wanted you to tell me how you got it. Okay, 25 is not divisible by 2, so I'm not going to divide it by 2 right now. I'll do it if I have to, right? So 45, 75, 45 is what, 30? So is 30 divisible by 2?
Yeah.
Yeah.
Yes. So then I'm going to take 15 times 25. So if I'm going to do it, I'm going to take 10 and then 5. I get 375. What do you guys get?
I got 375.
Trying to think when I started doing that, because it wasn't always. I think I had a math teacher one time that tried to teach me to do that. And I'm like, that's stupid. And then I started doing it when I was teaching because I was doing multiplying so often. It does speed it up. Questions on this? Can I throw you curveballs? Can I give you the sum and ask you for the first term and things like that?
No.
Could I?
You could. But
Yeah,
you
I could. And
That's what I don't want to do that.
well, it's like any other time. Okay. Find the indicated partial sum of the arithmetic sequence.
Okay.
So, this constant right here, that right there, I would plug 1 to 100 into this equation, yes? And every number I put in there, I'd multiply by what? 2 every single time. So doesn't it make sense that I maybe could do this? Take that out?
Take the 2 out?
Yeah. So could I find my answer and then just multiply the whole answer by 2? Because it would be, if I wrote this out, it'd be 2 times something plus 2 times something plus 2 times something, yes?
Mhm.
Well, couldn't I factor the 2 out because every single term has 2? What would be the benefit of factoring out the 2? What would happen with my numbers that I'm working with? They would be what? They'd be smaller. And is it pretty easy to multiply by 2 when you're done?
Uh-huh.
Yeah. So anytime we have a constant there, we're going to what? Kick it out. Every time. So we're going to rewrite this as 2, the sum of n equals 1 to 100 of n. So 2, and n is definitely arithmetic, correct? Even if they didn't tell me, it'd be 1, 2, 3, 4, right? We just did it. Okay. So, using my equation, what's the equation? S sub n equals
N divided by 2.
times.
A1 plus AN.
Okay, you guys already got it? Pretty much. Okay, so what's my n? 1 to 100. What's my n? How many things am I adding? 100. Divided by 2. That's a really big bracket. Times a sub 1.
1?
Yeah, 1. Because when we plug in 1, we would get 1, yes?
Plus 100.
Plus 100. So 2 times 50 would be, well, actually just do that, right? Reduce the 2's. So I get 100. So you get 100 times 101. So 10,100.
Say something and then change it.
Change what?
I said divide by 2, and then you're like, oh, you can reduce now, as I've already written.
Okay, that's fine. You can divide by 2 and then multiply by 2 if you want. Okay, do B on your own. Let's see if you can do it. Oh, Let's see if you can do it.
Where'd you get 50
From 51 to 100,
from? Is it 49?
but you got to add back in 51. If you take 100 minus 51, you're doing their spaces. Oh, wait, I didn't add right.
Where did you get 175 from?
25 times 7. Because this is 25, and then we have our 7. So let's see if I can add right this time. 15, 13, 14, 15, carry 1 is 8. So I got 18,550.
Why is it 50 over 2?
6,425 when you multiply it.
Why is it not 100 over 2?
Well, what do you?
Oh, yeah, I don't even know what I did. What? Okay, 50. Just a second, let me fix this since I can't multiply.
Miss Mick, it would be. It's 100 over 2,
Yeah.
not 50 over 2.
No, it isn't.
No.
No, it isn't. Okay, so 175, and this was 151, and your answer is 26425. Okay. How this n, remember I said this n was how many things you're adding. Yes? And if you're starting at 51 and going to 100, that is not 50 things. 100 things. That is 50. Now, the way you figure this number out, the easiest way is 100 minus 51 plus 1. So this would be 49 plus 1. Because when we subtract, we're counting gaps, like the spaces between the numbers, yes? But when we're plugging things in, we're counting actually what we're putting in. So when you subtract, you're forgetting 51. So when you get 49, you have to add back in 51. Is that making sense at all?
A little bit.
Okay. Do you understand why it's not 100 at least?
Yes.
Okay. That n, remember I said that n was different. When we write the definition, it's different than when we find the sum. So I wanted you guys to do that on your own so we could find those errors. Because I think you'll remember the fixing of them better. And I do not know what I messed up on that one. Oh, I do know now. Because when I multiplied by 5, I didn't put a 0. That's what it was. Because it should have been moved over. And then I would have had that number. Okay. Now what do you think I do on the next one?
Do both the problems and then minus.
Do both the problems and subtract them, right? Okay, so what is my n going to be on the first one?
11.
Well, I've got 30 minus 11 plus 1. So 30 minus 10, basically, which is 20. So I've got 20 over 2 times 11 plus 30 minus. Now the next one starts at 1, so am I easy? If it starts at 1, is it always going to be the upper limit? Yes. But are they always going to start at 1? Nope. So 10 over 2 times 1 plus 10. So 10 times 41 minus 5 times 11. So 410 minus 55. So 355? Maybe?
265.
Nope. 355. Because you got to borrow. You didn't borrow.
Oh, yeah.
When you borrow, it turns to 10. Okay, so that's what you're doing today. And I'm pretty sure we got through everything. We did. So just in time. Questions? Okay, we got to get the homework done tonight, guys. Because tomorrow we've got extra. What do I have? I think I have a math and I Excel down for tomorrow, don't I? Yes? Yep. So we got to get those down so we can answer any questions before you go through there.